Welcome to the session on interpolation. The study of interpolation is based on the study of finite differences. In the previous sessions, we discussed finite difference operators. Here, we derive an important interpolation formula by means of forward differences of a function, which is employed in engineering and scientific investigations. Newton's Gregory forward interpolation formula. Let y equal to f of x be a function which takes values y0, y1, etc., yn corresponding to the n plus 1 values x0, x1, etc., xn of the independent variable x. Let the values of x be equally spaced, that is, xr is equal to x0 plus r into h, where r varies from 0 to n. Here h is called the interval of differencing. Let phi of x be a function, be a polynomial of the nth degree in x, taking the same values as y corresponding to x0, x1, etc., xn. Then phi of x represents the continuous function y equal to f of x, such that f of xr is equal to phi of xr for r equal to 0, 1, 2, 3, etc., n. And all other points, at all other points, f of x is equal to phi of x plus r of x, where capital R of x is called the error term or the remainder term of the interpolation formula. Ignoring the error term, f of x is approximately equal to phi of x, which is equal to a0 plus a1 into x minus x0 plus a2 into x minus x0 into x minus x1 plus a3 into x minus x0 into x minus x1 into x minus x2 plus etc. in general plus an into x minus x0 into x minus x1 into etc. x minus xn minus 1. We can write f of x as a polynomial function. Here the constants a0, a1, a2, etc., an can be determined by putting x equal to x0, x equal to x1, and so on. If we put x equal to x0, we get f of x0 is equal to a0. That is, f of x0 means phi of x0, which is equal to a0. That is, y0 is equal to f of x0 means y0, which is equal to a0. The value of the constant a0 is y0 itself. Putting x equal to x1, we get f of x1, that is phi of x1, which is equal to a0 plus a1 into x1 minus x0. All the terms, remaining terms are 0 because all the terms containing x minus x0, sorry, x minus x1. that is this is equal to that is f of x 1 means y 1, which is equal to a naught is y naught plus a 1 into x 1 minus x naught. That is y 1 minus y naught is equal to a 1 into x 1 minus x naught is h, or this gives a 1 is equal to y 1 minus y naught divided by h. The value of constant a 1 is y 1 minus y naught divided by h, which can be written as delta y naught divided by h. Delta means the forward difference operator. In terms of forward difference operator, we can write y 1 minus y naught equal to delta y naught. That is a 1 is equal to delta y naught divided by h. Putting x equal to x 2 gives, if we put x equal to x 2, then f of x 2 is equal to a naught plus value of a naught is y naught, a 1 is delta y naught divided by h. A naught plus a 1 into x 2 minus x naught plus a 2 into x 2 minus x naught into x 2 minus x 1. All the other terms will become 0. This is equal to a naught is y naught plus a 1 is delta y naught divided by h into x 2 minus x naught plus a 2 into x 2 minus x naught into x 2 minus x 1. F of x 2 means y 2, that is y 2 minus y naught is equal to delta y naught divided by h into this x 2 minus x naught can be written as x 2 minus x 1 plus x 1 minus x naught. That is we add x 1 and subtract x 1 plus a 2 into x 2 minus x 1 plus x 1 minus x naught, that is x 2 minus x naught is x 2 minus x 1 plus x 1 minus x naught into x 2 minus x 1, which is equal to delta y naught divided by h into this x 2 minus x 1 is h plus x 1 minus x naught is also h plus a 2 into x 2 minus x 1 is h plus x 1 minus x naught is h into x 2 minus x 1 is h, which is equal to delta y naught divided by h into 2h plus a 2 into 2h into h is 2h square. From this we can write a 2 as a 2 is equal to here y 2 minus y naught, that is y 2 minus y naught minus delta y naught divided by h into 2, h and cancelled, that is 2 delta y naught. This term will become 2 delta y naught is equal to a 2 into 2h square. That is y2 minus y naught minus 2 times delta y naught is y1 minus y naught, that is equal to a2 into 2h square. That is y2 minus y naught minus 2 y1 plus 2 y naught is equal to a2 into 2h square. That is y2 minus 2 y1. This is 2 y naught minus y naught is y naught is equal to a2 into 2h square. This is y2 minus 2 y1 plus y naught is delta square y naught. Second forward difference is equal to a2 into 2h square, which gives a2 is equal to delta square y naught divided by 2h square. This is the constant a2. That is a2 is equal to delta square y naught divided by 2h square. 2 means 2 factorial. Similarly, by putting x equal to x3, we will get a3 as a3 is equal to delta cube y naught divided by 6h cube. That is delta cube y naught divided by 6 is 3 factorial h cube. And if we put x equal to x4, we will get a4 as a4 is equal to delta raised to 4 y naught divided by 4 factorial into h raised to 4 and so on. In general, we will get a n as a n is equal to delta raised to n y naught divided by n factorial into h raised to n. Now, we substitute these values of a naught is y naught, a1, a2, a3 etc. In this expression, we will get f of x as f of x is equal to this is equal to y naught plus a1 is delta y naught divided by h into x minus x naught plus a2 is delta square y naught divided by 2 factorial into h square x minus x naught into x minus x 1 plus delta cube y naught divided by 3 factorial into h cube x minus x naught x minus x 1 into x minus x 2 plus etc. plus delta raised to n y naught divided by n factorial into h raised to n x minus x naught into x minus x 1 etc. x minus x minus x n minus 1. Now, if we write u is equal to x minus x naught divided by h, setting u is equal to x minus x naught divided by h, which gives x minus x naught is equal to u into h. Now, x minus x 1 can be written as x minus x naught plus x naught minus x 1. Just add x naught and subtract the same. This is equal to x minus x naught plus x minus x naught minus x 1 minus x naught, which is equal to x minus x naught is UH minus x 1 minus x naught is H. UH minus H, that is equal to U minus 1 into H. Similarly, x minus x 2 is equal to U minus 2 into H. X minus x 3 is equal to U minus 3 times H, etc. X minus x n minus 1 is equal to U minus n minus 1, that is U minus n plus 1 into H. If we set U equal to x minus x naught divided by H, we will get x minus x naught equal to H and so on. Therefore, this expression for f of x can be written as f of x is equal to this is equal to y naught plus delta y naught divided by h into x minus x naught is UH plus delta square y naught divided by 2 factorial into h square. X minus x naught is UH into x minus x 1 is U minus 1 H plus etc. Next term is delta cube y naught divided by 3 factorial into h cube UH into U minus 1 H into U minus 2 H plus etc. plus delta raised to n y naught divided by n factorial into h raised to n UH U minus 1 H U minus 2 H etc. U minus n plus 1 H. That is f of x is equal to y naught plus u into delta y naught, h and cancelled, u into delta y naught means delta y naught divided by 1 factorial plus h into h is h square cancelled, u into u minus 1 divided by 2 factorial delta square y naught plus h into h is h cube and this h cube cancelled, u into u minus 1 u minus 2 divided by 3 factorial delta cube y naught plus etc. plus here u h into etc. up to h n times h. Therefore, h raised to n and this h raised to n cancelled. The remaining is u into u minus 1 u minus 2 etc. u minus n plus 1 all divided by n factorial delta raised to n y naught. This formula is known as Newton's forward interpolation formula. This is the Newton's interpolation formula. The Newton's interpolation formula is used to interpolate the values of y near the beginning of a set of tabular values. Now, we have an example that is the question is obtain y of f of 12 from the given data. The values of x are 10, 15, 20, 25, 30 and 35. The values of y are 35.3, 32.4, 29.2, 26.1, 23.2, 20.5. First of all, we formulate the forward difference table. The first differences are minus 2.9, minus 3.2, minus 3.1, minus 2.9, minus 2.7. That is 32 minus 4 minus 35.3 is minus 2.9. We calculate all the first differences, and the second differences are delta square y. The second differences are negative 0.3, 0.1, 0.2 and 0.2. The third differences are delta cube y 0.4, 0.1 and 0, and the fourth differences are minus 0.3 and negative 0.1. The fifth differences are 0.2. This is the corresponding difference table. Now, here u is equal to, here x naught is 10, x naught equal to 10, x is 12. Therefore, u equal to x minus x naught divided by h. Here h equal to the interval of differencing is 5. Therefore, u is equal to 12 minus 10 divided by 5, that is 2 by 5, which is equal to 0.4. By Newton's forward interpolation formula, we have y equal to, y means f of x, y is equal to y naught plus u by 1 factorial into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u minus 1 u minus 2 divided by 3 factorial into delta cube y naught plus etc., which is equal to, here y naught is 35.3 plus u is 0.4 divided by 1 factorial, delta y naught is this minus 2.9 plus u is 0.4 into u minus 1 is 0.4 minus 1 divided by 2 factorial is 2, delta square y naught is this minus 0.3 plus 0.4 into 0.4 minus 1 into 0.4 minus 2 divided by 3 factorial into delta cube y is 0.4 plus the next term is 0.4 into 0.4 minus 1 into 0.4 minus 2 into 0.4 minus 3 divided by 4 factorial into, next difference is this minus 0.3 plus 0.4 into 0.4 minus 1, 0.4 minus 2, 0.4 minus 3 and 0.4 minus 4 divided by 5 factorial into, next difference is this 0.2. On simplification, we will get the value of y as 34.2200704. This is the value of y at 12. Y of 12. Y of 12 means f of 12, which is equal to 34.2200704. We can approximate this as 34.2. Here, note that the 12 is very in the beginning. Therefore, we use the forward difference formula. The value of f of 12 is 34.2 approximately. Now, the another problem is we can find out the polynomial corresponding to polynomial function corresponding to a given set of data. For example, the given data is values of x are 0, 1, 2 and 3 and the y values are 1, 2, 1 and 10. The corresponding difference table is first differences are 2 minus 1 is 1, 1 minus 2 is minus 1, 10 minus 1 is 9. And the second differences are minus 1 minus 1 is minus 2 and this is 10. Third differences are 10 minus minus 2 is 12. This is the difference table. Here x naught is 0 and x is x itself, u equal to x minus x naught divided by h, that is here x minus 0 divided by h. Here h is 1, that is equal to x by 1 equal to x, that is u equal to x. Therefore, by Newton's forward interpolation formula, we have y of x equal to y naught plus u by 1 factorial into delta y naught plus u into u minus 1 divided by 2 factorial into delta square y naught plus u into u minus 1 into u minus 2 divided by 3 factorial into delta cube y naught, which is equal to, here y naught is first value of y is 1 plus u is x, x by 1 factorial is 1 itself, that is x into delta y naught is this 1 plus u into u minus 1 is means x into x minus 1 divided by 2 factorial is 2, delta square y naught is minus 2 plus x into x minus 1 x minus 2 divided by 3 factorial is 6 into delta cube y naught is 12. On simplification, we will get this as 2x cube minus 7x square plus 6x plus 1. This is the required polynomial, that is this is a cubic polynomial. We are given a set of data and obtained a cubic polynomial by using the forward interpolation formula. Let me conclude this session. In this session, we derived the Newton's forward interpolation formula, and we observed that this formula can be used to interpolate a value of the given function in the very beginning, and we can find out a corresponding polynomial function corresponding to a given data. Thank you for watching this session. We will meet again with another session. Have a nice day.